Hello and welcome in this lecture. Dear students, you have already learned about 5 types of substances which are solid, liquid, gas, plasma and VEC. Another topics you have learned: solids are not fluids, gases and liquids are fluids. Properties of solid substances, classifications of solid substance, difference between crystal and amorphous substance, unit cells, types of unit cells, types of centered unit cell, packing efficiency in simple cubic lattice, which is 52.36%, efficiency in body centered unit cell, which is 68%, and packing efficiency in hexagonal, which is 74%. Remember, the total number of atoms in simple cube is 1. Total number of atoms in body centered cube is 2, and in face centered number of atoms are 4. You have also learned types of defect: point defect, line defect. Types of defect: stoichiometric defect, and classification of stoichiometric defect is interstitial defect, Frankel defect and Schottky defect. Another means second type of defect is impurity defect, and third, non-stoichiometric defect. Types of non-stoichiometric defect is metal excess defect and metal deficiency defect. Now, numericals, which is for NEET, JEE and GUSSET students. First numerical, question 1. A solid compound is composed of X, Y and Z. X atoms are on corners, Y atoms are at the centers, and Z atoms are present on the centers of the faces. Determine the formula of the compound. The answer is, here X atoms are at corners of cube, means number of X atoms is 1/8 multiply 8 is equal to 1. Y atoms are at the center and number of Y atoms is 1. Z atoms are on the centers of the 6 sides, means 6 multiplied by 1/2 is 3. So, ratio of 3 atoms X, Y, Z is 1:1:3, and therefore the formula of compound is X, Y and Z3. Another numerical, sodium metal crystallizes in the incentered cubic close packed structure. What is the approximate number of unit cells in 9.2 gram sodium metal? So answer is 1 mole sodium means Na is equal to 23 gram Na, which means 6.022 into 10 raised to 23 atoms, Avogadro numbers. 1 mole sodium is equals to 6.00022 into 10 raised to 23. So 9.2 gram sodium contains 9.2 into 6.022 into 10 raised to 23 divided by 23 gram, which is equals to 2.4088 into 10 raised to 23. Number of atoms in the unit cell of insintered cubic closed peg is 1/8 multiply 8 plus 1, which is the insintered corner and insintered, so equals to 2. Number of unit cells 2.408 into 10 raised to 23 divided by 2, which is equals to 1.2044 into 10 raised to 23. After these numerical topics, magnetic properties of solid substances. In atoms, magnetic moment of electron can be produced from its two types of motion. One is the motion around the nucleus and second on its own axis. Thus, measurement of momentum of electron is done by in Bohr magneton. Its value is 9.27 into 10 raised to 24 am square. Substance can be divided into 5 types on the basis of their magnetic properties. First, paramagnetism, and the substance is paramagnetic substance. Paramagnetism is due to one or more than one unpaired electrons. Paramagnetic substances are weakly attracted in presence of magnetic field. In absence of magnetic field, their magnetism is removed. Examples of paramagnetic substance is Cu plus 2, Fe plus 3, Cr plus 3, O2, etc. Another property, diamagnetism. The substances which are weakly repelled by the magnetic field are called diamagnetic substance. The substance which have all paired atom, paired electron and number of unpaired electron is not present, so this type of magnetism is called diamagnetism. Third property is ferromagnetism. The substances which are strongly attracted by the magnetic field and which shows permanent magnetic property in solid state metal ions of ferromagnetic substance are arranged. Examples of ferromagnetic substance are Fe, Co, Ni, gadolinium and CrO2. Next property, ferrimagnetism. In these substances, the number of magnetic moment is small due to unequal number of magnetic moment of domain aligned in the parallel anti-parallel direction. These substances lose the ferromagnetism on heating. Examples of ferrimagnetic substances are Fe3O4. Next example, MgFeO4 and Zagan Fe2O4. Next property, anti-ferromagnetism. These substances have domain structure similar to these of ferromagnetic substances, but their domains are oppositely oriented and centered out each other's magnetic moment. Example, MnO. MnO is anti-ferromagnetic substance. Next topics and next numericals next time. Till then, goodbye.